Hello everyone, welcome. I'm so glad you could join me here today. And I'm really excited because I get to introduce you to the fantastic cross-platform Xamarin Forms framework. And I'm going to show you how to build a brand new application with Xamarin Forms using Visual Studio. Now before we get started, I should introduce myself. My name is Adrian Stevens, and I'm the Curriculum Manager for Xamarin University. But I'm not alone here today, and we're very fortunate to be joined by several Xamarin experts. And if during the presentation you have any questions or comments, please use the discussion box and they'll be more than happy to respond. I mentioned that I'm part of Xamarin University, and that means I get to work with some amazing people that create and teach classes for XAMU. And if you haven't tried it yet, Xamarin University is the place to go for the most comprehensive and up-to-date Xamarin-focused training. This includes a number of amazing things like live classes with expert instructors. You can also schedule one-on-one office hours with those instructors to work on any project or anything that you would like. There's an amazing Xamarin community, and this has a private forum just for Xamarin University students to interact with each other and the instructors. And you also have the opportunity to become a Xamarin certified mobile developer, and this is quickly becoming a benchmark certification. So if you'd like to learn more or enroll in XAMU, please head on over to university.xamarin.com. Now, Microsoft offers end-to-end tools for developers to create and publish mobile applications. Of course, we're going to talk about Xamarin today, and the Xamarin development platform lets you create native Android, iOS, Mac, and Windows applications, all in C#. We also have testing tools, and part of that is Test Cloud, and this is a UI testing solution. It allows you to write what we call outside-in or automated UI tests, and you can run those locally or on devices in our testing center. Now, the Xamarin build tools are responsible for compiling and packaging your code into native applications on each of your supported platforms. And when you're almost done developing, you're ready to do some testing, we have Hockey App, and this allows you to quickly deploy beta versions to your testers to ensure that your app is amazing before releasing it to the public. And once your application is published, you want to keep track of it. We have tools to monitor usage, track custom events, and even receive crash reports. And this is all being brought together in the recently announced Visual Studio Mobile Center. Now today, we're going to focus on creating and running a Xamarin Forms application. So we'll look at building a UI, sharing code across platforms, and deploying the app to devices and emulators. So let's talk development, and I'd like to properly introduce you to Xamarin Forms. If you watched the previous webinar, you know that one of the great features of Xamarin is being able to write your business logic in C# and share it across iOS, Android, and Windows. And using Xamarin iOS and Xamarin Android, you would then create a native UI. You would code that in C#. And this is great. It gives you the ability to customize the look and feel for each platform and easily leverage native controls on each platform. Now with Xamarin Forms, you'll still continue to share your business logic, but now you can place all of your UI definition, all of your UI code in a common location, and this would be typically a portable class library or a shared project. And what this means is that the amount of shared code for a cross-platform application can actually exceed 95%. And Xamarin Forms not only lets you share UI code, but it has a number of really significant development advantages. So it has over 40 UI elements, and this is what you'll use to create your UI, and these all ultimately create the appropriate native control on each platform. And we'll see how this all works in just a couple of minutes. You can also define your UI in XAML, and this is very much like the XAML that you've been using as a Windows developer for years. You can also take XAML and combine it with data binding. This lets you achieve a really strong separation of UI from your code behind. And Xamarin Forms includes a number of other really useful APIs, so things to help you with navigation, animation, and even dependency injection. So let's talk about platform support now. So Xamarin Forms supports iOS, and this starts at iOS version 6.1, but it goes all the way up to the most recent iOS 10 release. If we look at Android, it's a very similar story. Xamarin Forms supports Android 4.0.3, or for you Android developers, that's API level 15, and of course higher. And again, including the latest Android releases. If we look at Windows, it actually supports 3 different platforms. It supported Windows Phone 8.1 for quite some time, as well as Windows 8.1 Store, but it also includes the latest release of Windows, Windows 10, in the form of a UWP application. And one more thing I want to mention. Xamarin is now completely open source, and this includes Xamarin Forms. And because it's open source, you can download that source code, you can review it, see how things work under the hood, and you can even add features to extend the platform. And if you want to contribute, Xamarin does accept pull requests. So hopefully now you're getting excited about Xamarin Forms. And let's see what we need now to get up and running, and then we'll dive into some code. So as Xamarin developers, we can develop on both Windows and Mac OS. On the Windows side, we'll use Visual Studio, and this includes the free Community Edition. And we prefer to use the later versions, Visual Studio 2015 or the soon-to-be-released 2017. And if you use either of those versions, you can install Xamarin right from the Visual Studio installer. On the Mac side, you can use Xamarin Studio or the new Visual Studio for Mac that's currently in preview. Now, it's absolutely true that we can develop on a Windows PC with Visual Studio, even when creating iOS applications. But Apple licensing requires that we build the application on a Mac using the Apple SDK, included with Xcode. Now, Xamarin solves this through a service that's installed on a network-connected Mac. This comes with the Xamarin tools, and this service is known as the Xamarin Mac Agent. Now, Visual Studio for Windows can then connect to this process on the Mac and then delegate a portion of the build to the Mac, allowing us to compile with the native toolchain. We can also even launch the Apple-provided iOS simulators on the Mac. So now I'm going to switch over to Visual Studio and show you what it takes to make a brand new Xamarin Forms application. So I've got Visual Studio 2015 open with the Xamarin tools installed, and with those tools that of course includes the Xamarin Forms templates. So to make a new project, I would go File, New Project, and then under Visual C#, you see cross-platform and a number of Xamarin Forms choices. Let's look at this first one here. It says Blank App, Xamarin Forms Portable. And what that means is that our common code, our UI definition, and probably our business logic, we place in a portable class library. Now below, there's one called Xamarin Forms Shared. Very similar, but it'll put the common code, it'll create a default shared project instead of a PCL. Now notice there's Blank App and Blank XAML App, and the difference here is the initial UI that's created. They're both fairly hello world-like examples. The Blank App variants just create the UI in code, and the Blank XAML App, as you would probably expect, create some default UI using XAML. And of course you set your name and hit OK, and it would create a brand new project. Now, and then it takes a couple minutes to initialize all the different projects. I've gone ahead and done that ahead of time, just so we don't have to wait that minute or two for it to all load. And I made a Blank App Xamarin Forms portable called My First Forms App. So let's see what the template created for us. So our solution here has 6 projects. The first is our portable class library. This is our common code. This is where our business logic could go and our shared UI definition. And then we have our platform-specific projects. So this is what we'll actually run, and this is what actually deploys the native application. So we have one for Android, for iOS, and our 3 Windows projects. So I'm going to start our exploration in the portable class library in our shared code. And we see this app.cs. Now this is the application class, or what you can think of as sort of the main entry point in a Xamarin Forms application. And the application class does many things, but one of its most important jobs is to present the initial UI of your application. Now in the default template, it presents a kind of a hello world style UI. It says welcome to Xamarin Forms. I don't want to dissect this just yet, but it does define something called a label, and this is to present some basic text on screen. And we can see here that we see some center alignment, and the text says welcome to Xamarin Forms. So let's look at one of the platform specific projects and get a sense of how this is all wired up. Now on iOS, I'm going to open this up and look at the references, and we see that it's referencing the portable class library, and all of the other platform-specific projects will do the same. And we also see some Xamarin Forms references, and this is the platform-specific Xamarin Forms code. And really, this is what contains all of the logic that will take the Xamarin Forms UI definition and actually present it as a native control on this platform. And you'll see similar things on each platform. So on iOS, it'll take that label definition and present a native UI label, and similar behavior on the other platforms. So how's this actually wired up? Well, when we look at the app delegate, so this is really the main entry point of an iOS application. And if you're familiar, you'll know there's an application delegate class. Now what we have here is a slightly customized version, and this is customized by the Xamarin Forms team to allow them to intercept the lifecycle events. Otherwise, it's pretty much a standard application delegate. And finish launching is called when our app is finished launching. So you start up your iOS app, it finishes, and look what it does. It initializes Xamarin Forms. Then it calls this method called load application, and this application actually presents the native UI. This is going to be responsible for presenting the iOS UI. And look what it takes as an argument, an instance of our app class. And again, we saw that in our portable class library, and that's where our UI definition is. And so this here is going to be responsible for generating that native iOS UI. And we'll see very similar things on the other platforms. On Android, for example, we'll go to our activity. We see a slightly customized activity, again, to intercept those lifecycle events. That's just a convenience for you, but pretty standard otherwise. But we see similar code. We initialize Xamarin Forms. We call load application, passing in an instance of the app class. And now it's going to take that, but on the Android side, it's of course going to present a native Android UI. And you'll see very similar code in the Windows projects as well. So let's run our application and see what it looks like. I've got UWP selected already, so we'll start there. And here we see what looks like a native, very simple native UWP application. And we see that our label definition in Xamarin Forms has been translated to a native piece of UI. This looks very much like a native Windows UWP application. Very simple, but still native controls. Let's try the other platforms, and I'm going to move over to Android next. So we'll set this as the startup project and run it. Now you might notice here I've actually got a physical device selected. I'm going to run this on a tablet that's sitting beside me here. And so you can see what's going on. I've actually got a tool that lets me screen share. So this is my tablet. Our application deploys, and again we see welcome to Xamarin Forms, but again, this looks like a native Android application, very simple. We're seeing consistent UI, consistent fonts. It's just an Android application, and it is, of course, a native Android application because of this code here. It takes our cross-platform definition, and it creates the native UI. Let's do one more platform. Let's do iOS. Set a startup project, and I'm going to deploy this to an iPhone simulator. Now, we can't install the iOS development tools on a PC, and that means I don't have the simulator installed on my PC, but I do have it installed on my Mac. And I also have a tool called Remoted iOS Simulator for Windows, and this allows me to see the simulator running on my Mac. So we'll see our application loading up, and so this is actually happening on the Mac, but the visuals are being presented on my PC. And again, native looking iOS application because it is a native iOS application. And as we'll see later, this is more than just a visualizer. I can actually interact with the application as well. And very cool, if you're working on a touchscreen Windows device, it will translate those touch interactions to the simulator through the PC, over the network to the Mac, and you can actually touch and interact with your iOS simulator from your PC. So let's talk about building a Xamarin Forms UI. So what does it mean? What are the pieces? What do we have to work with? Well, Xamarin Forms defines its own UI elements, really its own UI API that we can use to construct our user interface. So we're going to start with a page class, and this is an object that encapsulates an entire screen of UI. And we have several different types. There's a content page that can be used to create a single screen application, or you'll often use it to define multiple pages that will then be used in common navigation patterns, and we see some here. Now we do master detail, stack navigation, tab, and we even have a carousel, which is something you can use to swipe between pages. So some of our very similar common navigation paradigms that we're used to on our mobile platforms. Then we have layouts. And Xamarin Forms layouts are used to help size and arrange the controls in your UI. So they're designed to make it easy to create a well-structured and even a reactive UI, something that can scale different screen sizes or even respond to orientation changes. And you see we have several layouts to choose from, including familiar styles like a stack layout. We have grid, so we could do things in rows and columns, and more specialized variations like absolute layout as well. And then we have the actual UI building blocks. These are the controls or the UI elements. And these implement the core functionality of your UI. And they're really what the user interacts with. So notice we have a lot of the common controls. Really, I would say all the most common controls are available directly from Xamarin Forms. You see we have things like our image and entry fields, labels, buttons, even things like time picker and date picker. And there's also a really active third-party industry, and it provides specialized controls, so you can definitely go beyond the default set. But this is what's ready out of the box. It really gives you all the power, all the building blocks you need to make a fairly complex UI. Now, Xamarin Forms has a very powerful data binding engine. This helps you achieve a really clean separation between your UI and your code behind. And it has all the features you'd expect, all the features you need, like commands and type converters, and this lets you build your UI using the popular model view model pattern. And when you think data binding, you often think XAML. And if you've done any Microsoft UI development, it's likely you've done some XAML development. And the structure of the XAML and how it works will be very familiar to you Microsoft developers, but the controls and elements you use to build your UI are a bit different. So, as an example, here we have a simple page defined for a WinRT application. It displays a text box, a password, and a button organized vertically. And the root container here is a page. And we use controls and layout containers that are specific to the WinRT world. Now, the same page in Xamarin Forms could look like this. We use the same control for text entry in both cases. One is marked as taking a password, and the button here has a text property, not a content property. And the root element for most Xamarin Forms pages will be content page. But you can see the similarity. Don't worry about the specific elements, but notice they're very, very similar in structure, but it is those controls, those elements that are different between the platforms. Now, the Xamarin Forms controls are abstract models. As we mentioned, for each Xamarin Forms control in your UI, you're going to create a platform-specific control at runtime. So, for example, in our Xamarin Forms XAML, we might use an entry control. When we run this app on iOS, the Xamarin Forms infrastructure creates a UI text field. On Android, you'll get an edit text, and on Windows, it'll be presented as a text box. And so this means that our Xamarin Forms UI, it really, really is a native UI. It's always creating native controls on every platform. Write your UI once, and it runs with a native look and feel. So I've opened up an existing solution that we'll use to demonstrate some Xamarin Forms UI development. Now our app is called DrumPad, and notice we are following a similar structure. We've got a portable class library for our shared code, and then our 5 platform-specific projects. I think the best thing to do is to fire this up right away and let you see it. And I'm going to demonstrate this using the UWP project. Now take a look at the UI and think, what types of elements might we use here? We see an image, we have some text, and then we've got our 4 gray boxes here, and these are actually buttons. These are touchable UI. Now watch what happens when I resize the window. Our buttons are scaling accordingly, so of course they're staying proportional to one another, and they're reactive. So we've done development on other platforms, HTML or other XAML languages. You might be thinking, grid could work here. Of course, there's lots of solutions. I'll take you over to the code and show you how we wired this up. Of course, our UI is in the portable class library, and we are using XAML this time. And it's all done in main page. I'm just going to walk you through the code here quickly. So right away at the top, we see that we're running this within a content page. As we mentioned, this is perfect for a single screen application, or again, you might use a content page to break out your UI for various navigation paradigms. For here, we're making a single screen application. Now this section here is our resources and styles. I'm not going to go too far into this. Again, if you've done XAML before, this should look familiar. And if you haven't, this is just a handy way of reusing values within your XAML. So for example, our buttons, we might want to apply the same background color to all of our buttons. And we don't really want to define that value in 4 different places. So we define a resource, really just a way of putting the value in a central location, and then we can apply that in multiple places. Now a style is just an extension. It goes a little bit farther than that. And what it does is it allows us to define a style for a type of UI. For a button, for example, we can apply values to several properties. So we can set a text color, a background color, and a font size as an example. Now moving on, we see we have a grid, and this is really defining our UI. And this grid has 2 row definitions and 2 column definitions. So we can imagine that it's broke up into 4 pieces. But you know what? Actually, I'd rather show this to you while we're looking at the code. So let's use a tool we have in our toolbox as a Xamarin developer. I'm going to go to View Other Windows, and I'm going to open up the Xamarin Forms Previewer. And what this is going to do is give us a near real-time preview of our XAML. And here we see our application, and we're previewing this in iOS. Of course, go between portrait and landscape, and we can also do an Android preview. Okay, that's much better. So now we can really correlate. So we can see how our XAML definition relates to our UI visualization. And hopefully you've got a chance now to digest some of the XAML. You can see we've got a grid defining our overall UI. And then we've got some sub layouts as well. So we've got a stack layout. This allows us to arrange elements either horizontally or vertically. In this case, we're doing it horizontally. It's going to house our logo and our application title. And then we have another grid within the grid, and then we're using that to lay out our buttons. And again, they have equally sized rows and columns, and our buttons placed within them. Also notice here we're applying our style. That's just our button style up top. So our text color, background color, and font size for our button. Let's add a little bit more UI. So I'm going to do a little pasting here to watch me type this all out. So I'm going to add another stack layout. I'm going to put it in column 1, which is actually the second column. So this is going to go on the right-hand side of our UI. And we could even go a little bit further to say grid row equals 0, but that is the default value. This means that we're in the top right-hand corner of our main grid, and our stack layout is going to arrange things horizontally. And we've got a label and then something called a picker, and the picker lets us just choose between multiple selections. Very often this is used with data binding, but it doesn't have to be. In this case, I'm just going to add some string values. Now for our label, I think we need some default text here. Let's set that. So I'm going to set the text property. And this is going to be our drum style for our drum sounds. It allows us to change between different drum sets. And our picker, we have our values in here, but we don't have as a default selected value. So I'm going to set the selected index as 0. And you can see here that our previewer is updating, and it's picked our second value, our rock kit. And of course, I could change this here. I'll change this to 1, and we see that update right away. That's picked up our second value. Now, the last thing I've done here that you might want to notice is that I've wired up the selected index changed event. This is going to call a method in our code behind. We'll look at that just a little bit later on. But what I want to do now is run the application. So let's run this first on UWP. And again, we see our application, and now we see our new UI, and here's our picker being rendered as a native UWP control. And if I switch over, let's try iOS this time, set as our startup project. Let's do our simulator again. And here again, we see our application. Here's our picker, our Xamarin Forms picker. But remember, it's just a model object, it's a definition, it's a description of a UI element. And so when we click this, it's actually rendered as a UI picker view, the native iOS control. And again, seeing our Xamarin Forms definitions being rendered as native controls. So now that we have our UI definition in place, it's time to start looking at code sharing strategies across our supported platforms. We have several strategies that we can use to share our code in our cross-platform mobile applications. So we can put our shared code in a portable class library, and that of course includes the PCL that was generated with our Xamarin Forms solution. Alternatively, we can create an additional portable class library, and then that compiled library would be referenced by each of our platform-specific projects. We also have the option of using a shared project and compiling the shared code directly into each platform. And keep in mind, both of these can also be used to hold application resources. And we can also incorporate third-party code from NuGet. So this is a really great way to take advantage of really the thousands of packages that are available from individuals, from corporations, and the general open source community. Now, sharing code across multiple platforms is great, and it's even better with Xamarin Forms, where we're sharing our UI definition. But there are times when you may need to access platform-specific APIs. You might want to leverage a unique feature on one platform, or you may need to implement a feature on all platforms that isn't currently available in the Xamarin Forms APIs. And I'll show you an example of this in just a moment. But just remember, we're running native applications, and that means that we're still able to compile and execute per platform native code. We just need a way to connect that native code to our shared code, and we have a few options. So we can expose public properties of basic types in our shared code and just assign them from the platform specific code, so often during the startup. A second approach would be to initialize a more complex type, maybe something like a stream, do that in the platform specific code, and then pass that into the shared code, again, via a property or a public method. Or if we require something more complex, we can define an abstraction in the common code, an interface or an abstract base class, and then create a concrete implementation in each supported platform. Then we just need to instantiate that platform specific implementation and pass that into the common code. Now let's switch back to Visual Studio and see how this all works. Now we're back in our DrumPad solution, and we previously expected our XAML UI definition. And when we create a XAML file in Xamarin Forms, we also get an associated C# file that's often referred to as the code behind. And these two files are intimately linked, and they both end up contributing to the class definition. So in our case, our page is called main page, and so both the XAML and its associated XAML.cs, its code behind, both contribute to the main page declaration. Now this file is also in our portable class library. This is in our shared code, and this is where I place the business logic for the DrumPad application. Now this app, although it's doing a few things, it's loading sound files, it's playing sound, generally it's a fairly simple application. It's a single screen app, and so it's absolutely reasonable to put all of your logic here in the code behind. It's not uncommon, however, in Xamarin Forms, especially on larger applications, to see a more structured architectural pattern. You'll see a lot of MVVM examples, but in our case here, this is nice and simple, a little bit easier to digest, so I've placed all of the business logic here in the code behind. So let's now think about what our application actually needs to do. Well, we need to respond to user interactions on those button presses and play a sound, play our drum sound for each button. Now currently Xamarin Forms doesn't have a sound API. Now it's possible that could change in the future. The Xamarin Forms team are always adding new things to the API surface, but for now there is no cross-platform audio solution. So usually the next thing you would do as a Xamarin Forms developer is go to the community, see if you can find a NuGet package, and there are several out there for cross-platform audio, but none of them that really fit my specific needs. I wanted to support all 5 platforms, and I wanted to be able to load the audio from the portable class library. And I wasn't able to find that exact solution, so I decided to implement it myself. Now fortunately for this application, my requirements were fairly simple. All I really need to be able to do was to play sound files. And so the first thing I wanted to do was create really some structure, a definition, or what we usually call an abstraction for my audio playback. So I created an interface called Simple Audio Player, or iSimple Audio Player. And all I really need to be able to do is load a sound and play a sound. But I added some basic functionality, possibly for future projects, so I could pause and stop as well. Now I'm going to create an interface in the common code, and then we'll implement this interface in the platform-specific projects. So let's head over to the iOS project as an example. So in the iOS project, we have a class called Simple Audio Player that implements the interface. And if you're not familiar with the interfaces, all this really means is it has to create the methods defined in iAudioPlayer. So it has to have a load method, a play, a pause, and a stop method. And that's exactly what I've done here. Now on iOS, you would typically use the AV Audio Player to play back Simple Audio. And again, exactly what I've done. And so you can think of Simple Audio Player in the iOS project as really a lightweight wrapper around the native AV Audio Player object. Again, load, play, pause, and stop. And we'll see something very similar in the other projects. If we go to UWP, for example, you'll see it wraps media element, again, load, play, pause, stop. And over on Android, it just wraps the Android media player object. And you'll see similar code, of course, in our Windows Phone and Windows 8 projects as well. It's actually very similar to the UWP implementation. So we have a concrete implementation on every platform. How do we wire this up to our shared code? Well, we've actually got quite a few options. And one of the simplest things we could do is just expose a public property in our common code. And the app class is a perfect place for this. Now, you might want to do something like this. We go public static, make an I simple audio player. Let's call this audio player with a getter setter. And then from each platform specific project, we could set this property. So we would go app.audioplayer equals new simple audio player in the Android project. Same thing in the iOS project, same thing in the Windows projects. And that would absolutely work, and that could work for this application. However, I didn't want to reload the audio every time we press a new button, and I also wanted to be able to play more than one sound at the same time. So instead of just a simple property, created a little factory delegate. And so we've got a create audio player method that returns, well, a create audio player delegate, I should say, that returns an iSimple audio player instance. So how do we wire this up? Again, we'll go to Android first. Over to the main activity. So again, here we see our Xamarin Forms initialization, and then after this, we're going to reach that delegate, that create audio player delegate, and we're going to point it at a method that returns an iSimple audio player. Well, really all we need to do is instantiate the Android specific implementation of Simple Audio Player. And so we new up Simple Audio Player that of course is defined in the Android project. And we see something very similar on iOS and very similar on UWP. Again, we just reach into that create audio player delegate and we point it to our Lambda expression that returns an instance of our iOS Simple Audio Player. So if you think about this, we're running this on iOS, right? The iOS project is running. The iOS project initializes Xamarin Forms. The iOS project then assigns the create audio player delegate, and then of course it loads the UI, which is then represented as iOS native controls. So it's always going to be accessing the implementation of iSimple Audio Player on the executing platform. And now we can just go ahead and call create audio player from our shared code, and it's always calling the correct concrete implementation. Now I want to pause here briefly and mention that there is an API called the dependency service that's included with Xamarin Forms, and it's another way of solving this problem, and it's a nice way of loosely coupling. It means that you don't have to have a direct connection from your platform specific code to your shared code, but I thought this was an easier way of digesting it. But definitely if you're going to do multiple abstractions or you've got more complex requirements, definitely take a look at the Xamarin Forms dependency service. So let's see it being used now in our shared code. We go back to our main page.xaml.cs, and we see here in our constructor, actually let's look up above. Notice we have an array of iSimple audio players. So we've got a collection of our abstract types, our iSimple audio player, and then we just loop through the array, and for each entry in the array, we call the create audio player delegate on our application class, again instantiating the correct version of our simple audio player. And then of course we can call the methods defined, the load, the play, the pause, and the stop on those instances. So we see here we've got our shared business logic. It's in our shared code. It's being used by every platform. And we're even able to reach some platform-specific code. Now I want to talk a little bit about sharing resources. Now I showed you earlier we've got an audio folder in our PCL with a number of WAV files with our audio resources. Now remember, our iAudio player interface defines a load method that takes a stream. And this was done because stream is available on every platform and it's usable within a portable class library. So if we go back to our code behind our main page.xaml.cs and we scroll down, so we've got some code to load the files. And the one I want to point out here says get stream from file, and really all we're doing is getting a stream from the resource embedded in the PCL. So we use this helper method to get the stream, then we pass that stream into the load method of the concrete implementation of our iAudio player. And of course then on every platform, that platform just has to make use of the stream to instantiate and use the native APIs. And I'll just quickly show you again on iOS. Notice here our load method takes a stream, and then we're very fortunate, we've got a helper method on NSData, this is an iOS specific type, that allows us to implement a native type from a stream and then pass it into the native AV audio player. And you'll see similar solutions on the other platforms. So there we go. We're actually able to share our audio resources as well as our business logic. And I've got one more quick example. We can also do this with images. So here we've got our logo PNG. I'll open a big version. This is the logo that sits in the upper left-hand corner of our application. Now, I'll mention it is very common to have platform-specific image resources in each of your projects. And if you've got an image resource-intensive application, generally a good idea. It allows you to include multiple versions for different resolution devices. But in the case of our logo, this is fine. We're just scaling it on every device, and it looks pretty good in most cases. And this is a nice, convenient way of doing this type of graphic. So we got our logo PNG. And if I scroll back up to our constructor, you can see here, this is our image logo as defined in our main page XAML. So we go back to our UI definition. Notice we've just given a name to our image. And then there are Xamarin Forms APIs to load the image from resource. It's just a one-liner. Drumpad is the assembly, and then logo.png. And of course, we could put this in subfolders as well. And this loads it from the portable class library onto our image. And again, we're now sharing image resources cross-platform. This will display on every platform. And the final bit of wiring now is to simply call the play button when our buttons are pressed. Now, because we've named our buttons in the XAML definition, it creates a field that we can use in our code behind, and the buttons provide a clicked event handler that we can subscribe to. In our case, we're calling an onDrum button method. And if we scroll down here, you can see we're just calling the play method on the appropriate implementation of our iSimple audio player, just the right index out of the array. So let's try it out. We'll use the UWP implementation, and here's our application again. But now, when I click on the button, we hear our drum sounds. And let's try another platform. Well, let's give Android a shot. Now, just remember, this is running on my connected tablet. This is on a physical device, so the audio will be playing on the tablet itself and being picked up by the microphone. So it might be a little bit quieter, but I think you should be able to hear it. And here's our application, again with our screen sharing. And hopefully that comes through okay. Again, we see it's working using the native Android audio APIs. And that just about brings us to the end of our demo. But I want to let you know that all this code is available on GitHub, and I'm going to provide the link for you in just a moment. It's all free, it's all open source, and it's all available for you to take, download, and use however you like. And I highly recommend you download the project and poke through it. See how all the API calls are working. Now, one thing you'll notice when you go through the code is this animation class here. Now, when we use the application and click the buttons went red and then they transitioned back to their original color. And that was done using the Xamarin Forms animation API. And in this case, what I've done is instantiated an animation object for each button and then just done a simple translation of color. And there's some code here. And I won't walk through it in extreme detail, but it's all here. Here's where the animations are instantiated, and then just a little helper method down here that helps get the blended color. So it blends from that red color back to its original color. And these animations are just triggered in the onDrum button method. Another thing you'll notice in the published code is the image logo. Now here, we wired up the image in the code behind by setting the source property of our image. But we can do this in the XAML as well. Now, there isn't a markup extension that's included in the API, but we can actually add one. I have one included in the project. So you open up image resource extension.cs. This is a new XAML markup extension that allows us to load that image from an embedded resource. And with this file in place, it's fairly easy to use. We can go back to our main page XAML. I'll bring in the namespace. I brought in a XAMU. It's part of our Xamarin University Infrastructure open source code. Definitely take a look at that. Lots of great stuff in there. And then if we come down to our image initialization, we can use it by setting the source property here. Use the namespace, image resource, and then just drumpad.logo.png. So if you haven't tried Xamarin yet, head on over to xamarin.com/download to get started. And remember, if you're using Visual Studio 2015 or 2017, you can also install Xamarin directly from the Visual Studio installer. And the best part, it's completely free. Now, if you're looking for more training, you're looking for more knowledge and content about developing Xamarin Forms, we've got some amazing training materials at Xamarin University. The first thing I want to mention, we've got free self-guided courses. They cover core Xamarin concepts with a big focus on Xamarin Forms. Again, completely free. You can register at university.xamarin.com. And if you're interested in the live training by our amazing expert instructors, head on over to xamarin.com/university. Again, those live courses, the one-on-one sessions with the university instructors, and that is your path to Xamarin certification. And so this brings us to the end of our presentation here today. Thank you so much for joining us. I hope you enjoyed it, and more importantly, I hope you learned a lot. If you have any questions, any comments, or any feedback, you can find me on Twitter at Adrian_Stevens, or you can email me at adrian.stevens@microsoft.com. But of course, if you have questions, our Xamarin experts are still here, ready to answer them. Ask them about Xamarin, ask them about today's presentation. And if you're looking for the source code, aka.ms/drumpad, or alternatively, you can find me on GitHub, Adrian Stevens. It's in my Xamarin Forms repository. And before you go, don't forget we've got more webinars coming. Chris Van Wyck and Judy McNeil will be talking about Xamarin iOS and Xamarin Android, and James Montemagno will be back to talk about Azure. Thank you again, and have a wonderful rest of the day.